Stealth jets have long been the most secretive aircraft in the U.S. military arsenal. Whether evading sophisticated air defenses on deep strike missions or asserting air superiority at supersonic speeds, stealth technology provides an unstoppable advantage in modern aerial combat. Air forces have always attempted to reduce the vulnerability of their aircraft by making them less visible. The traditional method to conceal them from enemy eyes was camouflage painting. However, since the development of radar in World War II, aircraft can be detected from hundreds of miles away. Radar can also be used to guide deadly anti-aircraft missiles with pinpoint precision. Stealth technology attempts to camouflage aircraft from radar, just as camouflage paint was designed to hide aircraft from enemy view. Radar works by projecting a focused beam of electromagnetic radiation which bounces off the aircraft back to its source. This reflected energy determines what the radar can and cannot see. The efforts to thwart radar began almost as soon as it was developed. Bombers would drop thin strips of aluminum foil called chaff. Carried by the winds, these strips formed huge clouds on enemy radar screens, making it impossible to determine the precise location of the attacking bombers. By the 1950s, advances in technology allowed radars to see through the obscuring clouds of chaff. Electronic jamming equipment was soon developed to disable enemy radar by overwhelming the reflected radar signal with a stronger false signal. But every new technology provokes a countermeasure. By the 1970s, jamming could be circumvented by new frequency-hopping radars. A curious little missile of the early 1960s suggested another approach to avoiding radar detection. The Quail decoy missile emphasized that the visibility of an airplane to radar was determined as much by its shape as its size. Certain shapes, such as 90-degree corners, concentrate radar signals and reflect them strongly. The Quail exploited these features so that it would appear as large as a B-52 bomber. The B-52 bombers could launch several Quails on false headings, confusing the enemy as to the size and location of the real bomber force. Since it was demonstrated that the shape of an aircraft could vastly increase its radar signature, research was undertaken to achieve the opposite effect: an aircraft that would appear smaller or even disappear from radar. This pursuit led to low observability technology, called stealth today. One of the first aircraft to incorporate low observability technology was the Firebee unmanned reconnaissance drone. Surfaces that reflected radar strongly were hidden deep inside the airframe. This robot spy plane also incorporated a new type of material as its skin, called RAM, for radar absorbent material. RAM soaks up radar energy like a sponge, making aircraft virtually invisible to radar. In 1966, another spy plane appeared in U.S. Air Force service, the legendary Lockheed SR-71 Blackbird. The SR-71 was one of the first manned aircraft to employ stealth technology. The Blackbird was not invisible to radar, but its use of radar-absorbent material helped reduce its visibility. Another example of low observability technology is the B-1B Lancer bomber. The original B-1, the B-1A, had a radar cross-section of 10 square meters, 10 times less than that of the older B-52. Advances in radar-guided missiles led to the B-1B. The B-1B version has a radar cross-section of about 1 square meter, 1/100th that of the older B-52 bomber. The success of the B-1B program proved that low observability technology could greatly reduce an aircraft's visibility to radar. But the challenge remained to design a plane that was virtually undetectable. In 1978, the U.S. Air Force contracted at the renowned Skunk Works at Lockheed Aircraft to begin design of a stealth strike fighter, codenamed Senior Trend. Unlike the SR-71 or the B-1B, the Senior Trend was designed from the ground up with low observability features. Tests had shown that by carefully shaping the contours of the fuselage, the aircraft's radar cross-section could be reduced dramatically. This resulted in the very unusual shape of the Senior Trend, later named the F-117A Nighthawk. The first flight of the F-117 took place in June 1981. Its development was so secret that pilots recruited for the program were not told their actual assignment. It was cloaked under a fictitious project aiming to improve the avionics of the A-7 attack aircraft.
When I entered the program, what I was told was I was going to be doing avionics testing on A-7s. And that's the premise we went in. And we were briefed on the program probably about a month or two after we started A-7 training.
I had maybe in the back of my mind 3 or 4 different things it could possibly be, but it wasn't until I got here they put us in the closed room and told us what the program was, and I went, oh, so this is what it is.
As unique as the F-117 appears, its novelty is only skin deep. To expedite development of this revolutionary design, the Nighthawk incorporated systems from a wide variety of military aircraft. The F-16 Falcon's flight control system, the Aces II ejection seat used in the F-15, F-16, and A-10, the environmental control system of the C-130 Hercules, and the GE-404 engines as used in the FA-18 Hornet. The use of off-the-shelf technologies not only allowed the program to remain secret, but also provided the designers with a track record of reliability and maintenance performance. Before the F-117 was officially named the Nighthawk, its engineers and test pilots referred to the awkward aircraft as cockroaches, since they went into hiding during daylight. Although this name is still sometimes used, by 1983, when the first stealth fighters went into service, their pilots quickly dubbed them the Black Jets. The nickname Black Jet stems from its special black paint finish, codenamed Iron Ball. This type of paint helps diffuse radar reflections. Each minute detail of the F-117 was carefully thought through to minimize radar reflection. Because engine fan blades are easy to detect, the Nighthawk's engines are buried deep in its fuselage. Its air intakes are covered by a special grille that minimizes the reflection of radar energy. Another common cause of strong radar reflections is the cockpit. On ordinary aircraft, the radar travels through the plexiglass canopy and reflects off the many objects inside the cockpit. On the F-117, the canopy is coated with a special metallic material to prevent the radar from entering the cockpit. An additional source of strong radar reflection is the wing-mounted missile pylon. So on the Nighthawk, the missiles are carried inside the aircraft in a special bomb bay in its belly. Even ordinary straight panel lines can reflect radar energy. To minimize these reflections, the majority of the aircraft is covered with special RAM. Where panel lines remain, such as here around the night sensor on the nose, the panels have a sawtooth edge to better scatter the radar energy. Although the F-117 is classified as a fighter, it was designed primarily for ground attack missions. Most strike fighters use radar to locate their targets, but the use of radar gives off an electronic signal that can be detected by an enemy force. The Nighthawk, therefore, uses a thermal imaging night sensor. The thermal sight picks up the temperature difference between objects on the ground and provides the pilot with a ghostly video image of the Earth below him. Ground attack missions have always been the most perilous aerial assignments. The Nighthawk was developed specifically for these missions. Its specialty is the most challenging: night attack. It is designed to sneak into enemy airspace undetected and attack pinpoint targets with laser-guided bombs and precision-guided missiles. The F-117 Nighthawk was initially flown by an elite group of pilots of the 37th Tactical Fighter Wing. These pilots were handpicked not just because of the secrecy of the program, but due to the demanding nature of night attack flying. Presently, the Nighthawk is flown by the 49th Fighter Wing at Holloman Air Force Base in New Mexico. The unique design of the Nighthawk provides exceptional combat capabilities. The single-seat, dual-engine aircraft has quadruple redundant fly-by-wire flight controls and is air refuelable, able to support U.S. missions around the world. Until the F-117 was publicly unveiled in 1988, the Black Jet was kept under a strict veil of secrecy. The aircraft were flown only at night to prevent spy satellites from viewing their unique shape. The radical design of the Nighthawk would suggest that it is very different to pilot compared to conventional fighters. However, in spite of its surprising configuration, it flies very much like other fighter aircraft. No matter how technologically advanced an aircraft is, they are never invulnerable. The first combat loss of an F-117 occurred on March 27, 1999, during the war in Kosovo. Using old Russian long-wave radars, Yugoslav air defenses were able to track F-117s, particularly when their stealthiness was weakened by excessive moisture or when their bomb bay doors were open. Since the F-117 carries bombs rather than missiles, it seems strange that it is referred to as a stealth fighter. The designation of the Nighthawk as a fighter rather than a bomber is reported to have been done in an attempt to misdirect foreign espionage. The F-117 Nighthawk first saw combat in 1989 during Operation Just Cause in Panama. It has since flown missions in Kosovo and has been deployed in the Middle East in support of Operation Desert Storm and Iraqi Freedom. Anticipating the need to incorporate stealth technology into future fighter aircraft, in the 1980s, the U.S. Air Force began the selection process for an advanced tactical fighter, narrowing the selection to two planes, the YF-22 and YF-23. A central factor in a plane's stealthiness is its shape. Whether angular in form as in the Nighthawk, or a smooth, sleek design as seen here on the YF-23 Black Widow II. These exotic shapes do not significantly impact bomber design, since there is not as great a need for speed or maneuverability. But fighters still require both speed and maneuverability, even in the missile age. Unfortunately, incorporating stealth features in fighters dictates sacrifices in their performance. In 1990, the YF-23, despite having a stealthier design, lost out to the YF-22. Renamed the FA-22 Raptor, it was chosen because it was easier to maintain, had greater flexibility for future development, and was cheaper to produce at approximately $150 million per plane. The main attraction of stealth fighters is that, in theory, it should be nearly impossible for the enemy to target. This gives a fighter with stealth characteristics the ability to fire many of its long-range radar-guided missiles well before the enemy fighters can even detect its presence. Stealth technology is not a magic potion that makes a plane invisible, but through careful design and combined technologies, the optimum mix of performance and stealthiness can be achieved. The Raptor has the most stealth features of any new fighter aircraft. The Raptor carries its AIM-120C AMRAAM missiles internally to preserve its stealthiness. Missiles are launched through hydraulic arms that deploy the AMRAAM so quickly that the weapons bay doors are open for less than 1 second per launch. The Raptor can fly supersonically in super cruise mode, reducing fuel consumption and avoiding the high heat signature associated with the use of afterburners. The first FA-22A Raptor was delivered to the U.S. Air Force in January 2003 and entered service in 2004. The Raptor is intended to replace the F-15 Eagle, an aircraft with an undefeated 104-0 combat record. The U.S. Air Force expects the Raptor to continue this impressive record well into the future. The low observability designed into the B-1B bomber made it far less visible to radar than older bombers. In the late 1970s, the U.S. Air Force set out to take the technology further, launching a secret program named Project Senior CJ. The results are evident in this remarkable aircraft, the Northrop B-2 Advanced Technology Bomber, later named the Spirit. The development of the B-2 was one of the best-kept secrets of all Air Force programs. Much about the Spirit remains clouded in secrecy even today, including precise information about the plane's radar cross-section. Although similar in size to the older B-52 bomber, the B-2 is likely several hundred times less visible to radar. It is impossible to make an aircraft completely invisible to radar. However, its radar cross-section can be reduced to such an extent that its radar reflection cannot be distinguished from normal background radiation. It has been suggested that the B-2 has a frontal radar cross-section similar to that of a large insect such as a bumblebee. The emphasis on stealth in the development of the B-2 was due to the mission of strategic bombers. The main threat to strategic bombers today is the radar-guided anti-aircraft missile. The features added to the B-1B reduced the effectiveness of radar-directed missiles by decreasing the range at which the bomber could be detected. Such weapons are even less effective against the B-2 bomber. The B-2's stealth features are contained in its unique shape. The B-2 looks very different from the F-117 stealth fighter, since it uses more recent stealth technology. The B-2 is essentially a flying wing. Its swept-back configuration has no vertical stabilizers or large tail surfaces to reflect radar energy. Its flight controls in the trailing edge of the wing are computer-controlled for stability. Its engines are hidden in the wings, with the air intakes located on top where radar cannot easily see. The surfaces of the bomber are covered with advanced RAM to further weaken the reflection of radar from its surfaces. Surprisingly, the Spirit is manned by only 2 crewmen compared to 4 in the B-1B bomber. The pilot and commander sit side by side in the cockpit. This significantly reduces the amount of intercom traffic you'd normally have in other large aircraft. The unique engine exhausts on the B-2 bomber and the F-117 fighter reveal another aspect of stealth technology. Since these designs so effectively counter radar detection, an enemy force might be tempted to use other means, such as infrared detection, to determine their location. Some Russian-made fighter jets, such as the MiG-29 and the Sukhoi 27, use infrared detectors to supplement their radar and are armed with infrared-guided missiles. The unusual engine outlets on the B-2 and F-117 contain design features to defeat infrared sensors and infrared-guided missiles. How these systems work is still highly classified. The B-2 Advanced Technology Bomber is currently estimated to cost over $500 million, making it the most expensive warplane ever proposed for series production. Some critics deemed the B-2 too expensive to be risked in combat. Their concerns were alleviated during the war in Kosovo in 1999, when the B-2 made its combat debut. B-2s flying from their home at Missouri's Whitman Air Force Base were used to deliver GPS-guided JDAM bombs. JDAM, or Joint Direct Attack Munition, is an upgrade kit fitted to older gravity bombs, giving them smart capability to steer themselves into pre-selected targets. This was the first use of these munitions in combat. B-2 Spirits also saw combat in Afghanistan in 2002, where after completing their bomb runs, refueled and changed crews at Diego Garcia Air Force Base off the coast of Sri Lanka. This was the first time the stealth bombers were seen in operation at a base other than Whitman. In 2003, B-2s were based at Diego Garcia for combat missions in Iraq. Future generations of aircraft, beginning with the FA-22 Raptor, will continue to push the envelope of stealth technology and design. But the B-2 Spirit and F-117 Nighthawk will go down in aviation history as the pioneers of this extraordinary technology.